MSG module, which is short for message. That'll contain string formatting functions. We also have math module that will contain math functions. We then need to update the main function to use the functionality from the module. We also have some notes here. The notes indicate that after moving the functions into modules, we should try run cargo check to get a listing of required code changes. So we'll go ahead and do that once we move some things around. So the first thing I'm going to do is actually create the modules. So we'll create a message module. We'll create a math module. Next, we need to move some functions into these modules. So here we have a trim function. As a message as a function parameter. So that's probably a message module. In this demo, I'll be showing you how you can test your code. Testing is an important part of software development. It allows you to ensure your code is working properly and keeps you advised if making changes breaks your code. Here I have a simple function. It just changes a word to all uppercase using the .toUppercase function on strings. If I want to test this function, I can create a test module. I'm going to call my module test. For test modules, you need to include a macro. And this macro will tell the compiler that this is specifically for testing. The macro for testing modules is CFG test. All we're doing here is we're setting a configuration option. CFG is short for configuration. And we're telling it that this is only to be used in testing scenarios. Within our test module, we can create another function. I'm going to call it check all caps. Our test function also needs a macro, and it is simply test. This macro tells the compiler that this function is testing other code. We can then test the all caps function. In order to test the function, we need a way to abort the program. The way testing works in Rust, if the program is aborted, then the test fails. But if the program does not abort, then the test succeeds. We can abort the program using an assert macro. I'm going to use assert EQ. Assert EQ will make an assertion that one value is equal to another value. And if that assertion does not hold, then the program will abort, thus failing our test. The assert EQ macro takes 3 arguments. The first is the value we want to check. The second is the value that we're expecting. And the third would be a message we can display when the test does not work. I'll create a few variables for our information. We'll have the result be all caps. And we'll just put in a word, hello. We'll then create another variable called expected, and we expect to get a string back, and the string should have the value of hello in all caps. Finally, we can now assert that this is what we get. So we have our results. We're asserting that it is equal to the expected result, and if it's not, then we'll print out a message. There's one last thing we need to do before running this test, and that is to use the all caps function. If you'll recall from the module demo, each module can be thought of as a separate file. As a result, this test module does not have access to our all caps function, since the module is completely self-contained. We have to use this all caps function in order to have access to it here. To do so, we supply the use keyword followed by the create keyword, and I'm just going to use the asterisk to bring everything into the module. In the Rust ecosystem, a collection of code is referred to as a crate, so all of our code could be considered one crate. When you use crate in this fashion, it just refers to the very top of your code, which in the case has the main function and the all caps function. We then access all of the functionality in our crate, which will give us access to all caps and main within our test module. Now that we have access to the all caps function, we can test it. To do so, go to terminal, new terminal, type in cargo test. Your code will be compiled and ran, and then you'll see a message indicating that they're running some tests. If you have more than one test, it'll tell you the number of tests being ran. As you can see, we have the test module here, as indicated in our code, and we also have the test function, check all caps. It says OK, which means the test passed. And here we have a result of all tests. It'll tell you how many passed, how many failed, how many were ignored, how many are measured. Measured would be measuring the performance, and how many were filtered out. It's possible to ignore and filter tests based on arguments that you pass to the cargo test command when you run it. However, we're just going to be running all the tests every time. If you want more information on how to set up different test scenarios, you can run cargo test --help. It'll list out all the different possibilities you can use in order to specify exactly which tests you want to run in which scenarios. Let's make this test fail so we can see what happens when the test does not work as expected. What we can do is just change this to hello in all lowercase. As we know, our function should return everything in uppercase, but now we're telling the test that we expect it to be in lowercase. But we know that it'll end up in uppercase because our function has 2 uppercase in it. Let's run this test again and see what happens. Here we can see that the test failed. So it lists out the test just as it did. It indicates that it failed. It then lists out all the failures that occurred. Here we can see that the assertion failed. So left is not equal to right. What that means is this result is not equal to the expected result. It then lists out what was provided to the assert macro. It says on the left side, we have hello in all caps. And the right side, we have hello in lowercase, along with our assert message that we provided in the code. It says string should be all uppercase, which is what we supplied here. So when you create your tests, it's always good to have a reason why it failed. That way, when the test fails, you'll see quite easily, we have a left value in all caps, a right value in lowercase, and a message saying, hey, the string should be all uppercase. Finally, it lists out all the failures. So if you have multiple tests, it'll list out which tests failed. When you're writing your tests, it's always a good idea to test something that's on the extreme end of the spectrum. What this would mean is if your function deals with numbers, you would want to try the smallest possible number and the biggest possible number, and then it's safe to assume that everything in between will probably work just fine. In our case, we're just checking to see if some letters get turned to uppercase, so this test should be sufficient for this particular function. As your programs get larger, it's always a good idea to write tests for your code. They not only ensure that your program works as expected, but they provide a safety net for when you make changes. You may make a change that seems small, and if you run the program, it may work as you think it works. But if you have a test, it may reveal that you made a subtle change that you didn't realize, and now your test fails, which means your program may not be running as expected. So tests are extremely valuable in ensuring code quality within your programs. This concludes the demo on testing. I'll see you in the next presentation. In this activity, we'll be utilizing testing to ensure that our code runs properly. Once you're ready, open up Visual Studio Code and we'll get started. Once Visual Studio Code loads, open up your activities directory. We are on activity 22, so double click on A22. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. All right, let's get started. This activity topic is on testing. The requirements are to write tests for the existing program. In this demo, I'll be showing you how modules can be used to organize your code. Modules help keep your code self-contained and easier to follow. Here we have a program that has 4 separate functions. We have 2 functions that print out information, and we have 2 functions that perform mathematical functions to discover new functionality. Your program when you group them up into modules. One important thing to note about modules is, as you can see, we aren't using any functionality here. We just have functions defined. So each module can be thought of as its own file of source code. And so there's nothing used in the particular greet module. If, for example, we wanted to use the hash map from the collections module in the standard library, the hash map would only be available to the main function, because the module has its own version of different using statements. So if we wanted to use hash map within greet, we would then have to use it like that. Just think of modules as their own individual file. So if you have additional functionality you want to use from the standard library, you'll need to have a using statement within the module itself in order to access it. This concludes the demo on modules. I'll see you in the next presentation. In this demo, I'll be showing you how modules can be used to organize your code. Modules help program. They can go straight functionality. Hash map within greet, we would then have to use it like that. Just think of modules as their own individual file. So if you have additional functionality you want to use from the standard of different users in the standard hash map from the own file here, the modules. One important thing to note about modules in your program, the math module operation, you can tell which function came practice to the function you'd like to use from the greet module, and you don't care about the rest of them, you can just use it directly by typing in the name of the function you want to use. So now we can use the hello function directly, but if we wanted to use the goodbye function, we still need to type in greet goodbye. It's good practice to list out each function specifically that you'd like to use. That way you're able to tell which function came from which module, just in case multiple modules have. Next, we need to move some functions into modules. Inline modules allow you to organize your code and easily access it. Once you're ready, open up Visual Studio Code and we'll get started. Once Visual Studio Code loads, navigate to your activities directory. We are on activity 26B, so double click on A26B. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. All right, let's get started. So the topic for this activity is inline modules. We have a brief summary about what we're doing, so I'm going to read it real quick. We have an existing program that's complete, but all the code exists in a single module. And this code can benefit from being organized into multiple modules. So we're going to be moving some code around for this activity. Requirements are to organize the code into 2 modules based on their functionality. So we're going to have a MSG module, which is short for message. That'll contain string formatting functions. We also have a math module that will contain math functions. We then need to update the main function to use the functionality from the module. We also have some notes here. The notes indicate that after moving the functions into modules, we should try running cargo check to get a listing of required code changes. So we'll go ahead and do that once we move some things around. So the first thing I'm going to do is actually create the modules. So we'll create a message module. We'll create a math module. Next, we need to move some functions into these modules. So here we have a trim function, and it has a message as a function parameter. So that's probably a message module function. So give myself a little bit of room, and I'll just copy that in there. And we have another one, capitalize. We're not going to worry about the function bodies because all of these should work fine. I know this return value is a little bit crazy, but we're not concerned with that right now. We're just concerned with moving these functions around. So I'm going to grab this cargo check -- bin A26B. We should get some errors that tell us what we should be doing next. So if we scroll up to the top, you always want to start from the first error because fixing the first error can sometimes lead to fixing all the subsequent errors. In this case, it won't, but a lot of times it can. So our first error is cannot find function add in this scope. And it tells us a line number 50. So it says that this add function was not found. But it also recommends that we can consider importing this math function. So it tells us we can use create math add. I'm going to do something a little different than what it recommends, but most of the time, this should work fine. Let's jump back into the code.
Yeah.
So what I'll be doing for the math functionality modules, I'm going to access the module directly. So I can do math and access the module directly. So this will go into the math module and then access the add function. I'm going to do that for all 3 of these math functions. So now we should be able to perform the operations because we're accessing the math module located here. So for example, down here, we have the multiply function. So we're accessing the math module here, and then we access the multiply function. And so then we'll be able to get the functionality that this function provides. The next thing I'm going to do is access the modules for the messaging functions. So I'm going to do something that the compiler recommended, which was a use statement. I'm going to start by creating a new scope with curly braces. I'm just going to move all of this content into those curly braces. There we go. So what happens with the scope, which is initiated by an opening curly brace and a closing curly brace down here. Once we get to the closing curly brace on the bottom, everything within those curly braces should be destroyed. That includes any using statements that we have, which imports modules. So that means we won't be using it once we get to the end curly brace. So if we use the MSG module, we're going to use all of 3 of these functions. We're going to use trim, we're going to use capitalize, and we're going to use exciting. So all we got to do is type those in. And we always end a using statement with a semicolon. So I'm going to save that. And now we should be able to access these functions. So we're using the message module, and within the message module, we're using all of this functionality. So all of this functionality here is available to us within this curly brace and the one down here at the bottom. So we can use those three functions anywhere within those curly braces. And we have three usages. We have trim, capitalize, and exciting. So let's hop back into a terminal and we'll run cargo. We can use those three functions anywhere within those curly braces. And we have three usages. We have message module. We're using all of this functionality. So all of this functionality here is available to us within this curly brace and the one down here at the bottom. So we can use those three functions anywhere within those curly braces. And however, the things that are inside the module are only accessible inside the module itself. So we can't access any of these functions from out here, only from within here. In order to fix that, we need to use the pub keyword to make it public. So pub for public. So we'll just add that. And we'll do each function, we're going to make it public. And we'll go ahead and do the math functions as well, because we're going to get the same errors. Now that the functions are public, we should be able to access them outside of the modules. And we'll run a cargo check again, just to make sure. So I'll hop back to a terminal, do cargo check, and no errors, and everything checks out. So now I'll run the program and we'll see what we get. To run the program, I'll do cargo run --bin A26B. So the program ran and we have some output. So that means we've completed the activity. As long as the program compiles and runs, then we're done. Before we finish up, let's go back and look at the code one more time, just to ensure that we understand how the module system works. So we'll just look at the math module. So we're creating a inline module. We're naming it math. We have public functions. So these functions here, they're accessible outside the math module, but we still need to use the name math when we access them in order to know where they come from. If we go down to our main function, we have two ways that we can access the functionality. So we can access it using the name of the module, the path selection operator, which is 2 colons, and then the add function, which is one of the functions that's defined. So we're doing that 3 times for each of the functions in order to calculate the results. The other way is with a use statement. So I'm creating a new scope. That way this use statement is only valid within that scope. So here we're using the message module and we're selecting the capitalize, exciting, and trim functions within this message module. When we have a use this way, we're able to use these directly. So we don't need to type message every time we want to access them because we're just using these things directly. So we can see they're being used here, here, and down here. And it works properly because we have the using statement right there. This concludes the activity video on inline modules. I'll see you in the next presentation. In this demo, I'll be showing you how you test your code. Testing is an important part of software development. In this activity, we're going to be creating a program that utilizes B. We're using all of this functionality. So all of this functionality that's defined. So we're doing that 3 times. It insights to the activity topic. All right, let's get started. This activity topic is on testing. The requirements are to write tests for the existing program to ensure proper functionality. Our notes indicate that we need to create at least 2 test cases for each function. We can use the cargo test command to test the program. And there's an additional note stating that we have bugs in the program that need to be fixed. We should read the documentation comments for each function to determine how they should operate when they're operating correctly. The first thing I'm going to do is split the view so we can see our test code and our program code side by side. Next, I'm going to create a test module, and I'll include the macro to designate it as a test module. The CFG is setting configuration, and we're just saying that we're in the test configuration, and the test configuration means we will only compile this when we're testing code. Next, we need to make sure that we're using all of the functionality within our tests. So we can use crate with the asterisk to bring all of the functionality into the module. So we'll have clamp, div, concat. Main is also available, but we won't be using that. So these will all be available within our test code. I'll start with the clamp function. As we can see from the description, it ensures that n is greater than or equal to the lower value and also less than or equal to the upper value. So it just ensures that it's between these 2 numbers, and we know that we have the equals there too, so it can include the lower and upper values. We're not going to check the body right now. We know there's bugs because the comments said that there's bugs, but for right now, we'll just try it with some basic input just to make sure our tests are okay. So I'll test for the lower bounds first. So we're going to be testing just the lower portion. I'll create a test function. I'll name it clamp lower. Make sure that we put in the test macro here. And this tells the compiler to run this function as a test. Next, I'll create some variables. The first one will be the results of running this function. So we'll call the clamp function. We'll supply values of 10, 100, and 1000. Since the clamp function ensures that the value n is in between the lower and upper values, when we call clamp, we should get back 100. Since 10 is less than the lower value, it should be set to this lower value. Our expected results is going to be 100. And to make sure that this properly tested, we need to use assert EQ as a macro. We're just going to assert that the results is equal to the expected value. And if not, we'll put a message, should be 100. Let's run this test first, just so we can get into the workflow. To run the tests, we go to terminal, new terminal, and then we can just do cargo test. We are on activity 22. So do --bin A22. And here our clamp lower function works out okay. Our test passed. And so we're looking good. I'm now going to test the upper bounds of the clamp. So if we just copy this function and use the same code and just change this to upper, and we're going to change the values as well. So we'll leave the 100 and 1000 here, and we'll just change the end value. So I'll change this to 5000. So 5000 is much larger than the 1000 max. So this 5000 should be changed to 1000 by the function. Our expected result is going to be 1000, and we'll just change our message to should be 1000. I'll run the test again just to make sure we're okay. It looks like lower and upper are working properly. Next, let's check the div function. So this just divides 2 values. I'm just going to name this first test check div, and we're just going to have a result. We'll do 1 divided by 1. Our expected value is 1. This function returns an option, so we have to make sure our expected result is wrapped in an option by using sum. We could then do the assert EQ macro, and we have our results, our expected results, and should be 1. Remember to add the test macro, and if we run the tests, we see that all our tests are passing so far. Lastly, we have the concat function, which takes 2 strings and places them immediately one after another. So I'll write a test for that one as well. So our results is going to be concat. I'll just do letters. So we'll concat A and B together. Our expected results is going to be an owned string. So we have an owned string here. So we need to create one in our expected results. And if we're placing them immediately one after another, as indicated here, it should be AB as our expected result. Finally, I'm you do an assert EQ, make sure that the result is equal to the expected result. And if not, I'll leave a message. Finally, I'll add the test macro so it gets ran as a test. And
중요한 건 저거 해시태그하고 대괄호하고 테스트 저번에 mod 테스트가 저 때만 런한다는 거랑. So mod test CFC, so this only runs, mod test only runs when you're testing CFG because of the CFG test. And each test has the hashtag.
I'll just that there is indeed a space there. If we just take out that space, the test should pass without problems. In this check conditions in order to pass. None. Otherwise, we're going to do the division operation. This and
test bin. cargo run 대신에 test bin.
We know that also. In this demo, I'll be showing you how to use external crates. External crates are a way to include other people's code within your program, thereby increasing your productivity and making it easier to write complex applications. Before I start adding external crates to my code, I'm going to create a new project. I want us to take a look at the files that are created when a new project is made. Here we have our source directory, where we include all our source files. We have a main file that's created for us, which just prints out hello world. We have a .gitignore file. This file is just used by source control, and it ensures that the correct files get checked into source control. We won't be covering source control in this course, but all source control does is ensure that your code is always available and that you can undo any changes that. In this demo, I'll be showing you how to use external crates. External crates are a way to include other people's code within your program, thereby increasing your productivity and making it easier to write complex applications. Before I start adding external crates to my code, I'm going to create a new project. I want us to take a look at the files that are created when a new project is made. Here we have external crates. In this demo, I'll be showing you how to use external crates. External crates are a way to include other people's code within your program, thereby increasing your productivity and making it easier to write complex applications. Before I start adding external crates to my code, I'm going to create a new project. I want us to take a look at the files that are created when a new project is made. Here we have our source directory, where we include all our source files. We have a main file that's created for us, which just prints out hello world. We have a .gitignore file. This file is just used by source control, and it ensures that the correct files get checked into source control. We won't be covering source control in this course, but all source control does is ensure that your code is always available and that you can undo any changes that might break your programs. And lastly, we have a cargo.toml file. The cargo.toml file is used to configure your project. At the top, we have some basic information about our project, and the dependencies section is where we will include our external crates. We can also see that there is a link here for additional information about the toml file and how different parts can be used. I'm now going to be adding an external crate to my project. To do so, we need to go to the crates.io website. Crates.io is the official repository for external crates in the Rust ecosystem. There's also an unofficial site called lib.rs, and lib.rs categorizes and ranks different crates. For now, I'll just use crates.io. I'm going to use the human time crate. Human time is simply a crate that takes seconds and minutes and converts it into a friendly user time. So it could convert something like 300 seconds into 5 minutes. That way it's easy for a person to understand. I can click on human time. On the crates page, we have all the information we need to use it, including additional links, the author, license, etc. This section right here is what we need to copy into our cargo.toml file. You can click on the clipboard icon, and it'll automatically copy it to your clipboard. After that, we can then just paste it into our dependency section. Here, we're telling the Rust compiler that we want to use the human time crate, and we want to use version 2.0.1. After that's done, we can jump back into our source file. Now that the external crate has been included with our project, we'll need to check the documentation for the crate in order to learn how to use it. We can see here we have a documentation link, so I'm going to click that. And then here is the documentation for the human time crate. It's also possible to generate this documentation if you run cargo doc on the command line. I'm going to use the online resource for now. We can see that the human time crate has a description about what it does, and we can see all the items that it exports, such as structs, enumerations, and functions. I'm going to be using the format duration function. As we can see, the format duration function formats a duration into a human readable string. We can see that the function accepts a value, and that value must be a duration. If we click on the duration, we'll then be linked to that specific type, and the duration type is part of the standard library. To create a duration, we can use from seconds and then supply the number of seconds that we want to use for our duration. I'm going to jump back into the editor and make the necessary changes we need to utilize this functionality. So here we are using the human time crate, and we're specifically using the format duration function. The format duration function is listed here under the human time crate, along with a description on how it's to be used and some examples of how we can use it. Next, I'm using the duration type from the standard library. As we can see from the documentation on duration, a duration type represents a span of time typically used for system timeouts. We can use a duration to represent a specific time span, such as 20 seconds or 5 minutes, or just a few nanoseconds. When you work with a duration, it will just print out the actual number of seconds or nanoseconds. But if we use the human time crate, as we are here, we can print it out in a friendly manner, including hours and minutes and seconds. And that's what we're doing here. First, we just create a new duration from seconds. We're creating a duration that's 9,876 seconds. And then we're going to call the printline macro and use the format duration function that we imported from the human time crate. This function should then format it in a human readable fashion and see what we get. When you first execute cargo run, it will update the crates IO index, which is just getting the latest information on all the external crates. If you haven't downloaded the crate yet, it will do so automatically during this step. It will then compile both the human time crate and then your crate. In my case, it's called demos. Once it's done, it'll run it as usual. And as we can see, this duration that was created is actually 2 hours, 44 minutes, and 36 seconds. There are tens of thousands of crates available on crates.io for download. All you need to do, again, is just add the name and the version that you wish to use into your cargo.toml file. You can also see that a cargo.log file has been created. The cargo.log file is used to keep track of exactly which versions of which dependencies are being used. It's not something you normally need to edit, but you can take a look through it if you want to see exactly what's being used by your application. Sometimes these dependencies, such as human time, they may have additional dependencies with them, and they would be listed here. As we can see, human time does not have any additional dependencies, so that's the only package that we have included. This concludes the demo on external crates. I'll see you in the next presentation. We can also see that a cargo tool, and as we can see, this duration that was created is actually 2 hours, 44 minutes, and 36 seconds. There are tens of thousands of crates available on crates.io for download. All you need to do, again, is just add the name and the version that you wish to use into your cargo.toml file. You can also see that a cargo.log file has been created. The cargo.log file is used to keep track of exactly which versions of which dependencies are being used. It's not something you normally need to edit, but you can take a look through it if you want to see exactly what's being used by your application. Sometimes these dependencies, such as human time, they may have additional dependencies with them, and they would be listed here. As we can see, human time does not have any additional dependencies, so that's the only package that we have included. This concludes the demo on external crates. I'll see you in the next presentation. 44 minutes and usual. And as we can see, the editor and make the necessary changes we need to utilize this functionality. So here we are using the human time crate, and we're specifically using. In this activity, we'll be creating a program that utilizes external